Hi everyone and welcome back to my channel. Today we're going to be continuing our lesson on CO2 car wheel style designs. So we're going to be continuing on with the same work that I finished off with in my last video. In the last video I showed you how to select a car length and how to select a front axle position, and we completed the CO2 car up to this point, which is just a rail car, which just shows axles drilled into the body, and any body work, meaning any body design, has not been shown yet. So this is just a simple rectangular blank yet. Eventually we will get into some lessons on how to design the racer itself, but right now we're just focusing on selecting a wheel design style. So taking a look at the hub in the CO2 cars module, we're going to take a quick look at this note, CO2 dragster design and construction notes. So we're going to be focusing on the first one today, which is shell cars, meaning the wheels are hidden inside the body. So that's what you're seeing on these examples here. When you look at the car from the side view, you cannot see the wheels. You can only see the bottom of them, if that, because they're totally inside the car. And this is a real neat design. It's for aerodynamics. It's really sleek and smooth, as you can see, right? Creates less drag to have your wheels inside the car. It's a little more work to build the car this way, but it's a preferred result. Versus rail cars, which you see here, this is an example of the wheels being totally on the outside of the car and with just an axle hole being drilled through the body, which is how my blank looks at this time. You can design your car to look however you want, because you're the designer. You're free to do a rail car, a shell car, a reveal car, or a hybrid car. So we'll talk about all of them. So let's take a look at the project outline sheet again. Okay. So if we're going to be drilling larger holes to shell a car out, we're using 1 3/4 for the rear and 1 1/2 for the front. This is hard to see in this drawing, so we'll take a look at the chart. Rear wheel diameter, rear wheel well diameter, 1 3/4 inches, and the front wheel well diameter is 1 1/2 inches. So these are the two sizes we're going to use for our side view in terms of circle diameter. So if we go back to our drawing, we're going to use center diameter circle, snap to the center of the axle hole, and draw this circle at 1 3/4. Enter. The front one is 1 1/2 inches. So that's right click, left click, repeat circle, find the center, and then type 1 1/2. Whoa, something went wrong there. Let's try that again. Center diameter. There. Okay. Now we're cooking with gas. So these wheels, they're not wheels, but they're wheel wells, need to be moved to the hidden layer. Now, why do we do that? Because it's a shell car. When we look at the car from the side view, we won't see the wheels inside the car. We're not actually drawing the wheels here. All we're doing is we're drawing the hollowed out space where the wheels will sit in the racer. We're not actually drawing any hardware. We're not drawing any wheels, axle bushings, axles, CO2 cartridges, washers, screw eyes, none of that stuff. We're just drawing what we're shaping out of wood for this project, what you're manufacturing from scratch, not what you're purchasing. So we're going to trim the bottoms. So select trim, select the bottom of the car as the boundary, right click and then left click and trim the bottoms of these wheel wells away. They have to be trimmed because, again, they're not actually part of the wheel system. It's just, again, it's a hollowed out space. Okay, so our center lines now have to be adjusted to suit these new circles. So we're going to have to grab your center line and extend them to the quadrant. And then pull out with a grip 1/4 inch per side. Do the same thing for the top here. And the same thing here. Last one. Okay. Now, you need the quadrant snap to do this. So make sure it's turned on. If you're not able to pick it up, you can go into the object snap settings by right clicking here, left clicking snap settings, and making sure that quadrant is checked on. In my case, it was checked on. Yours probably won't be. So you can go in and then check this on, and then you'll be able to do what I just did. Alright, so we'll hit OK. Alright, so our side view is looking complete now for a shell car. So now we're going to take a look at the top view. So what we're going to do now is grab a line, find that quadrant, and pull a line up to perpendicular, like this. And then right click, left click, repeat line, do the same thing again. Right click, left click, left click, right click, left click, enter, escapes the command, and so on. Alright, so now we know where the wheel wells begin and end for the front and the rear. So we're going to trim what we don't need. So let's hit the trim command, pick this line as your boundary, and then trim away these lines here. Okay. Again, because we're looking at this from the top view, we don't notice the wheel wells from the top, so these lines have to be turned to the dark side, hidden lines. Okay. Now, some students look at this and they think, oh, that's not very good. Look, my rear shell wheel, this CO2 cartridge hole drills into the end of it, and it's not going to work. So this, I need to change this. I can't do a shell car. Well, yes, you can, because if you look at this from the side view, it's just the way it presents. So you can see here that the cartridge hole doesn't meet the rear wheel. There is just enough space here, if everything is laid out and drilled in the correct position, that the rear shell wheel will not meet up with the CO2 cartridge hole. So you're good. It just looks that way from the top view because this, from here down, from the top view, this cartridge hole is covering that. It kind of looks like it's interfering, but it really doesn't. So, just in case you were wondering, everything's good. Alright, so now we need to decide how far we're going to be drilling in from the inside out. So in the manufacturing process, we're going to be cutting the blank in half, and we're going to be drilling each side from the inside out and then gluing it back together. So let's take a look at another sheet here. Let's look at CO2 card design process in AutoCAD and pencil drawing consideration. So these are things to consider while you're designing your types of cars. Okay, so CO2 car design process. Shell wheels, which is what we're talking about right now. it says wall thickness on each edge for the rear wheels only should be no more than 1/8, preferred, or as thin as 1/16. So when you're designing a shell car, your rear wheels should be at the most 1/8, at the very least 1/16, or somewhere in between. So I'm basically really giving you the information you need to know to get your shell wheels to work properly on your rear of your car. So we are going to offset 1/8, enter, and offset from here down and from here up. Okay, so that is what 1/8 looks like. What we do to one side, we have to do to the other because there's a center line representing symmetry. So let's trim the extra lines. So this one, this one, this one, and this one. And then this line and this line are turned to a hidden line. Okay. Now, the axle hole passes through the middle, but we're drilling this from the inside out. So we would have drilled our axle hole first before cutting it in half. So that means after we cut it in half, we've drilled these 1 3/4 inch holes in diameter from the inside out each side. We're plowing away and removing the axle hole in the middle here. So this has to be trimmed out. So we're going to use this line and this line as boundaries, and we're going to trim away the axle hole there. So the only axle hole that remains is where it's solid, where the wall thickness is here, here, and here. So this line and this line, this one and this one can't exist in a shell wheel style, right? Because this hidden line here makes no sense beyond this line because it's solid material in these corners. So they have to be trimmed. So this and this are your boundaries, and then trim these corners. And now that looks correct. So that is how the shell style wheel looks at the rear with a 1/8 wall thickness. Now we can go less than this. We can go up to a 1/16. Let's do an offset and see what that looks like just for a second. So that's half, right? This is the bare minimum you can go. If you leave less than a 1/16, you're really risking breakage. The material that we use, or the stock I should say, is basswood. It's a very strong wood in delicate areas, but you can only stretch it so far. And if you go less than a 1/16, the chances of you breaking the wheel well wall are great. So something to think about. I'm saying 1/8 preferred, but you can go less. So how about this? Why don't we erase that line, and why don't we look at 3/32s, which is between 1/16 and 1/8. There. So let's do this to both sides. Let's make that hidden, and we'll just make a little adjustment here. So we'll bring this whoops. Okay? And then we're going to trim. And then we have just a little bit more trimming to do. We got to trim the axle hole touch. Okay, and that gives you a little more room in the wells, and it's still enough to be pretty strong here. It's better than a 16th, but not quite an 8th. So I didn't have to do that again, make it shallower, but I wanted to show you how to edit it if you wanted to change it, right? So it's up to you, but I'm pretty happy with this, and I'm going to leave that the way it is for now. I probably won't be changing it again. So now we have to look at the front wheel. And again, the front wheel is not very critical. It says wall thickness for the front wheels is not critical because I listed here that your front GTLX CO2 car wheel width, this is a shell wheel, which is 3/8 wide. It's pretty narrow. You got plenty of room in your racer to place those wheels. Now this is for the rear. The rear shell wheels are 9/16, so they're fatter and they have more of an opportunity to rub together if you don't drill the hole out enough. But this is pretty relaxed here. So I would say I would go no less than 3/8. And if we measure this, we get 7/8. So basically you've got a 32 on each side, right? So look how much material you have here in terms of wall thickness to get away with versus here. So you could actually shorten this up. You could make it the same as your rear wheel if you wanted, or you can leave more material here on your wall. It's really up to you. But this is where I would leave it at least. I mean, you wouldn't be drilling any more than this, because then, well, I shouldn't say that. It wouldn't be drilling any less than this, because then you would end up possibly crowding the wheels and they wouldn't fit. So I'm actually gonna erase these lines. I want to leave myself a little more room. I'm probably gonna select quarter inch wall. Like that. Just to be different from the back. That's plenty of room for my wheels to sit. You can pick any size you want, right? Because you're the designer, right? These lessons are primarily just for process, show you how things are done. So we're going to trim. We're going to do this the same way we did it with the rear. Trim all the access lines. Boundary. We're going to trim out the middle axle hole, and we're going to trim out the wall in the corners. And that is perfect. So that works. That would work perfect for a shell car design. Thank you for watching. The next time we talk, we'll show you how to design a reveal style car. I'll talk to you later.